So in in AI, multicollinearity is a statistical phenomena that can arise as a challenge in machine learning and AI models. It occurs when two or more independent variables or features in a dataset are highly correlated, meaning they carry overlapping or redundant information. Now, what is the definition of multicollinearity? So, multicollinearity refers to the situation where independent input variables in a predictive model are highly correlated. High correlation between features makes it difficult to determine the individual impact of each feature on the dependent variable. High correlation between features high correlation between features makes it difficult to determine the individual impact of each feature on the dependent variable. Now, causes of multicollinearity. So, what are the causes of multicollinearity? It's like feature engineering, creating new features, for example, polynomial or interaction terms, can lead to redundant information. Then, data collection, variables inherently related, that is, height and weight in human data, or collected with overlap measurement processes. Then, domain specific knowledge, real world processes often involve relationships between variables. Then encoding categorical variables with many levels can result in multicollinearity if one level is a linear combination of others. This is very interesting. Now, indicators of multicollinearity. Variance inflation factor suggests multicollinearity in a feature. Condition number. A high condition number of the feature matrix indicates multicollinearity. High pairwise correlation coefficients between features indicate pairwise potential, indicate multicollinearity. High pairwise correlation coefficient between features. Unstable coefficients in regression models can vary significantly. Coefficients in regression models can vary significantly with small changes in data. Then, reduced model performance. Overlapping information can reduce the interpretability and predictive power of the model. Overlapping information can reduce the interpretability and predictive power of the model. Overlapping information can reduce the interpretability and predictive power of the model. Now, effects of multicollinearity. So, instability in model coefficients. In linear models, for example, linear regression, logistic regression, multicollinearity makes it hard to interpret individual feature importance. Multicollinearity makes it hard to interpret individual feature importance. Reduced interpretability, difficulty in identifying which feature contributes more to the output. Overfitting risk, Redundant variables can lead to overfitting, particularly in complex models. Numerical instability, high multicollinearity can cause numerical issues in optimization algorithms. Increased computational cost without adding valuable information to the model. So that is the inefficiency. Now, examples of multicollinearity, house price reduction, features like number of room and house size in square feet are likely correlated. Finance data variables like net profit and gross profit are often linearly dependent. In natural language processing, multicollinearity can occur when using dense embeddings or manually crafted features. Methods to detect multicollinearity, correlation matrix, analyze pairwise correlations between features, then compute variance inflation factor for each feature to assess redundancy, principal component analysis to reduce dimensionality and identify redundant information, eigenvalues of covariance matrix, small eigenvalues indicate multicollinearity. Small eigenvalues indicate multicollinearity. Regression diagnostics. Look for inflated standard errors in regression coefficients. Regression diagnostics look for inflated standard errors in regression coefficients. Inflated standard errors in regression coefficients. Methods to handle multicollinearity: remove redundant features, drop one of the correlated variables based on domain knowledge or feature importance, and combine features, use dimensionality reduction techniques like PCA or feature engineering to combine correlated variables. Regularization, apply techniques like rich regression or lasso regression. You regularize to penalize redundant features. Then increase sample size, collect more data to mitigate the effects of multicollinearity. Transform variables, use log or polynomial transformations to reduce correlations. Avoid dummy variable traps. Drop one dummy variable when encoding categorical features. Now, multicollinearity in specific AI models, linear models, regression, logistic regression, most affected by multicollinearity due to direct reliance on feature coefficients. Tree-based models, decision trees, random forest, XGBoost, less affected since these methods split data based on feature importance rather than coefficients. Neural networks can tolerate multicollinearity to some extent, but redundant features may still increase computational cost and risk of overfitting. Multicollinearity in feature selection. Multicollinearity in feature selection. During feature selection, multicollinearity can lead to misleading feature importance scores. Multicollinearity in feature selection. During feature selection, multicollinearity can lead to misleading feature importance scores. During feature selection, multicollinearity can lead to misleading feature importance scores. Technique like recursive feature elimination or embedded methods can help identify and mitigate redundant features. Techniques like recursive feature elimination or embedded methods, techniques like recursive feature elimination or embedded methods can help identify and mitigate redundant features. Now, multicollinearity and interpretability. In explainable AI, multicollinearity complicates explanations as it blurs the individual contributions of the correlated features. By addressing multicollinearity effectively, AI practitioners can improve model interpretability, stability, and performance. Thank you.